Good afternoon, everyone. So now we are going to discuss about the data storage and data analysis comparison in big data analytics. Comparison between the traditional system and big data storage and analytics. So in this topic, we are going to discuss about the storage systems. Already we know the storage system, how we are going to save the data, and also how we are going to after that save, how we are going to retrieve, how we are going to update. These are the some possible options for data storage areas. Traditionally we are using a lot of methodologies in older days, but now we are using latest technologies also we are using. Before going the traditional systems, now we are going to discuss about the traditional system of data storage. This is the topic of traditional systems. The traditional system is structured data. We know the structured data. Structured data means we can't change the structure of data. So already predefined one. User cannot be defined. That is called as traditional data. For example, RDBMS data and such as the MySQL database enterprise server and data warehousing methods. This and SQL is a language for managing the RDBMS relational database. Example: MySQL, PostSQL, Oracle database, Informix, IBM, and Microsoft SQL servers. These are the traditional systems we follow. In traditional system, we following only for the structured database. Structured means the top to bottom already we are predefined one. We cannot change that structure. We cannot change the structure. So already we are following that structure. The examples are RDBMS, MySQL, and SQL, Oracle database. These are the traditional data systems. Next, we move forward. So semi-structured data. Semi-structured data means this is also for traditional system. Semi means already we are defined. Already some people are defined. We are also modifying something. We are also modifying something that is called as semi-structured. XML and JSON and comma separated values, comma CSV. These are the files are using for traditional data. These are the files are using for traditional data. So traditional means already it's in older days, already fixed or already we are following that. Already most of the days we are using that is called as traditional. Okay, so next, so enterprise data. Enterprise data means we know the enterprise. So data warehousing, enterprise data warehouse store the database and data stores offer the integration using tools from number of sources. The enterprise means we know the more number of places, more number of companies, stores, all the places we are collecting the data, store the data, that is called a warehouse. It's a large place. Okay. So in this place we using more data, metadata. What is metadata? Data about the data is called as metadata. So, sir, connect network on this. Sir, connect network on this. அதுவே வந்துருச்சு வெளியே. நான் கொடுத்துட்டுங்களா? பழசுல இருக்குமா? வெளியே வருதா? Good afternoon, another person here. Now we are going to discuss about the data analytics or big data. So data storage we are going to discuss. Data storage and data analytics, comparison between the traditional systems of big data storage and analytics. So in this topic we are going to fully discuss about the data storage and analysis and the big data storage areas. So now we are going to discuss about the traditional systems. So traditional system, we know the traditional system means in this place we are using for structured data. Structured data means we cannot change the structure. Already we are, some people are fixing the structure. We are following that only. So for example, RDBMS such as the MySQL, enterprise server and data warehousing. In SQL language for managing the RDBMS relational database. Examples of MySQL, so Oracle database, Informix, IBM, Microsoft SQL servers are used for traditional systems. So traditional means already in old days, most we are using that system. We are following that system, that is called as traditional system. The traditional systems, another phase of the traditional system is semi-structured data. Semi-structured data means we are fixing, we are modifying something. We are modifying something, that is called as semi-structured data. XML, JSON, comma operated values, files. These are the files are using for traditional systems. Okay, so this is called as traditional system. Next we go for enterprise data. So enterprise data service for data warehousing areas. The enterprise data service means most of the data warehousing methods are used for enterprise data. Most of the companies, stores, and all the places we are collecting the data, we are using the data. So that is called as enterprise data warehouse store and database. Data stores after the integration using tools from number of sources. More number of places we are going to collect the data. That is enterprise data server we are going to use for this methodology. So for next, big data systems. So no SQL database considered as semi-structured data. No SQL data. Without SQL, we are using the data. That is called as no SQL data. Big data stores using no SQL stands for no SQL. Not only SQL, the stores do not integrate with application using the SQL. Without SQL, we are going to store the data. That is called as no SQL data. In traditional systems, we follow, this is the traditional system, we using the SQL data, MySQL data. But in big data analytics, is totally big data analytics totally changed. We are not using the no SQL. We are not using the SQL. That is called as no SQL database. Why we go for the no SQL? Means it's a large volume of data. Big name itself, you know, it's a big data. Huge amount of data we are going to store. So we are not. SQL is not enough for the store the data. So we are going to use another methodologies, different methodologies we are going to use. So that is the reason we go for no SQL methodology. This is the big data storage methodology. This is the enterprise data integration management with big data for high performance computing. So enterprise data, why we go for the big data means the full it is a corporate industry oriented places we using for the big data. So the large and huge volume of data we are going to store in this place. So the SQL is not possible to store that huge volume of data. So we go for the enterprise integration management system. This diagram is the enterprise management system integration diagram. So we using for step. We using 4 steps. One is a SOA enabled data service. It is used to store the high volume of data. SOA enabled data and ERP, CRM systems, flat files, XML data, JDBC and ODBC connectivities are possible for. It is used for data cleaning and reduction, warning and ETL data migration. These methodologies are we using. Next one is Oracle and Oracle database we using for in this place in third place. The fourth we using for Oracle data integrator with the enterprise server we using. The fifth one is data reports and data visualization methods. And one is data analysis and data text analysis, noisy text analysis, natural language processing, analytical with social network managing pages. Graph database is also possible for the enterprise data management with big data. This is the enterprise data integration management with big data for high performance computing. This diagram, in this diagram, we are not using the SQL. This is a no SQL data management system. No SQL data management system. We are using in big data enterprise integration data management. Why we go for the enterprise data management is we using the block. We are going to store the large amount of huge volume of data. So we go for the enterprise data integration management for big data. The next one is co-extents for traditional server data, NoSQL and Hadoop and Spark and compatible big data clusters. So in this place, we using for clusters. So we are going to big data clusters. We are using million byte and beta byte. Million of bit in clusters. Cluster means we are going to grouping. So millions of data, billions of beta bytes or data. So we are grouping. Hadoop distributed file system we using for in big data. Hadoop distributed file system using for the big data. So high volume, billion and terabyte social media data, messages, pages, emails, text messages, text files, not only for SQL, no SQL, operational database stores for operating systems, documents and images and videos using for in this big data analytics. And traditional RDBMS we using for data warehousing and computing logs, web servers, enterprise servers we using for traditional RDBMS and SQL database and Oracle database. But in big data analytics, we are using for Hadoop distributed file system (HDFS). The short form of the Hadoop distributed file system is HDFS, using for Spark and in this Hadoop distributed file system, we are going to store for high volume of million terabyte. Data are stored for high volume of billion and terabyte social media, text messages, emails, text files, MySQL servers are using for in this data. Okay, so we using our Hadoop distributed file system and enterprise. This diagram is this enterprise data integration management systems are using for big data analytics. Next, we go for big data platform, data management, storage, and analytics. So now in innovative non-traditional methods for storage and processing analytics. Now new innovative non-traditional method. Traditional method we using SQL servers. New innovative non-traditional method using for big data analytics. Distributed data stores, creating scalable as well as elastic virtualization platform for cloud computing. Virtualization platform for cloud computing we are going to use. So apart from the traditional methodology, so in non-traditional methodology we are using for enterprise learning or distributed file systems. This type of file systems are we are going to use and store the data in big data. Why means it's a large volume, large amount, million, billion, trillion amount of data we are going to store for the big data analytics. That's why we go for the non-traditional methods. The next one is big data platform management, storage and analytics. Huge volume of data we are going to store. Huge volume of data we are going to store. Message parallelism, high-speed networks, high-performance processing, optimization and tuning methodologies are used. Data management model based on not only for SQL or no SQL. So data management models also used for big data analytics. The next one is big data platform data management and storage analytics. In memory data column formats, transaction processing, dual in memory data columns as well as row formats, OLAP, OLTP. These are the possible for big data analytics. Data retrieval, mining, reporting, visualization, and analytics. Retrieval means we are going to for storing data. We are retrieving. Mining means we are mining. We are taking what we want. That type of data only we are going to take. That's mining. Reporting means what time we are going to take the data. Visualization is some visual effects. We are going to use the data management. In analytics, we are going to analyze. We are going to check. We are verifying the data. That is called the data analytics. Okay, next we move for that. So in graph database also possible for the big data analytics storage. We are to enable the analytics with social network messages, pages, and data analytics. Graph database also possible for the Hadoop distributed file systems. In traditional system, SQL servers, this is not possible for this type of data management system. In machine learning, other approaches are possible for the big data analytic, big data management systems. Okay, so these are non-traditional methods. No SQL methods are no SQL methods are following using Hadoop distributed file system only. The next one is big data sources is data sources, warehouse, Oracle big data, and sensors, audit of financial transaction data, external data, webs and social media, healthcare records are possible for big data platform data. The next one is Hadoop based big data environment. Already we know that the diagram. Already we are discussing for diagram. Mainly we are going for Hadoop distributed file system. Why means high volume of data, high volume billion and billion tera on social media and messages, pages, emails, text files. Not only for SQL, no SQL database we are going to use. Big data stack. The stack consists of set of software components and data store units. Stack consists of set of software components and data store units, applications and machine learning, algorithms, analytics, and visualization tools. Stack means stack approach are using for big data analytics, data management. So in this place, we using first applications and machine learning and algorithm, analytics, and visualizations are using. The next one is using for big data stack at the cloud service, and Amazon is doing also private cloud. Stack uses the cluster of high performance machines for big data stack. The next we go for the traditional and big data analytics as a reference model. This is the first one is a traditional model, second one is a big data model. In the traditional model, we are not using for data visualization, advanced analytics method. Predictive and prescriptive analysis are not possible, and data and SQL query, this type of methodologies we are not possible for. In map reducing methods also possible for in big data analytics. In our traditional model, we have data store and data warehousing, event stream processing, component event processing also possible. There is no possible for map reducing method, and data analytic methods and predictive and prescriptive analytics are not possible. Reporting and data visualization also not possible for traditional systems. Enterprise data source, external data source and big data sources are possible for in big data analytics. These are the some differences for traditional and big data analytics methods. Next, for Breakly data analysis stack. Not Breakly data analytics stacks, BDAS, consists of data processing, data management, resource management layers. Data processing software component provide in memory processing, process and data efficiency across the frameworks. So that is called as BDAS. BDAS means data processing combines with path streaming and interactive computations. Resource management software component provides a sharing and infrastructure across the various frameworks. So next one is there is a 4-layer architecture of big data. What is Apache, Spark, HDFS, Hadoop. Apache, Spark, HDFS, and Hadoop Yarn MapReduce method. These are the 4-layer big data stack. Apache, Spark, and HDFS. Next one is Hadoop Yarn MapReduce methodologies we are going to use. Finally, we go for the summary. In traditional database, RDBMS data, MySQL, enterprise server, data warehousing are using. Big data system, traditional and big data analytics architecture reference model. So we learned that Hadoop based big data environment, big data Hadoop based environment is a non-traditional model. It is a nowadays we are going to use. Finally, Breakly data analytics stack method we are going to learn for this topic. So end of the session, we are going to learn about the data storage and analysis, comparison between the traditional data and approaches of big data storage and analysis. So finally, one time we are go through all the slides. And mainly focus on we are going to do data management system in big data. So in this topic, we are going to compare the traditional methodologies and big data management systems. In traditional methodologies, we are going to use for SQL methodologies and MySQL databases are used. But non-traditional methodologies and semi-structured databases are used. But enterprise data warehousing not using, we are using for traditional methods. But big data systems we using for NoSQL and no enterprise data method. Using for high performance enterprise data integration management with big data for high performance computing we are going to use. So we using the Hadoop distributed file system. We are using billions of data we are storing the systems. New innovative non-traditional methodologies are used for big data analytics. So also we are going to use for that OLAP and OLTP data retrieval, mining, reporting, and visualization methods are used. Graph databases are used. Machine learning methods are used. So on big data sources, we use it for data source, data warehousing, big data are used. But in sensors and financial transaction, web from social media, weather data, health records also possible for big data analytics. This is a Hadoop-based big data environment diagram. This is a Hadoop distributed file system architecture. So the traditional structure, semi-structured data only million bytes, million, billion, trillion bytes are possible for big data analytics data management. We use my Hadoop distributed file system. Big data stack we are going to use. How we are going to use in stack methodology in big data. And BDS big data using stack, how we are going to use. Traditional data we are going to compare for traditional and big data analytics. We are going to compare these two things. We are discussing in this topic. So briefly, data analytics stack methods also possible for big data analytics. And also this combined with big data BDAS, it means we are combining with batch streaming and interactive computations. And resource management software component provides sharing infrastructure across various frameworks. This is 4-layer architecture diagram. This is 4-layer architecture diagram. We are going to use for Apache and Spark and STFS, Hadoop method we are using. So this is the final summary of this diagram. So we are traditional data systems, RDBMS and MySQL using big data traditional big data analytics architecture, reference models also using BDAS using big data environment also using. So these are the summary of this diagram. End of the session, we are finally know that what is the difference between traditional and non-traditional data management system. Non-traditional management system using big data analytics only. Why means we are going to store more volume of huge volume of data. So thank you for the viewers. Thank you. Thank you. Hello. Soluma.